First thing we need to know is what an inverse operation means. That just means the opposite. So for instance, if I am multiplying, the opposite would be divide. And if I'm adding, the opposite would be subtraction. And that goes both ways. So we have to use an inverse operation to solve these equations. So the first thing, whenever I say solve an equation, that means isolate the variable, which means I only want to see this when I'm done. M equals, and then the answer. I want that M by itself. I don't want the plus 118 next to it. So I take the plus 118 and I do the opposite. So if it's plus 118, I'm going to subtract 118. And since it's an equation, that means the two sides are equal. So whatever I do to one side, I have to do the other side in order to keep them equal. So I'm going to subtract 118 from the other side. So from the left side, that just equals 0. So now M is by itself, because M plus 0 is just M. 207 minus 118 is 89. If I want to, I could plug it into the original equation to check it. So 89 plus 118 is, in fact, 207. All right, so example 2, I see P minus 520, so I want to do the opposite of minus 520, and I want to add 520. What I do to the left side, I have to do to the right side. So the left side, negative 520 plus 520 equals 0. So P equals, and when I add these together, I'm going to move that 23 out so they're lined up correctly. I'm going to get 543. And if I plug that back in, 543 minus 520 does, in fact, equal 23. Next one, so I see n plus 10. I'm going to subtract 10. So on the left side I get 0, so the n is by itself. The right side I see negative 18 minus 10, so I can do this however I want. If I'm good at this and I don't need to change anything, then go ahead and do it. If you need to think about subtraction and change it to addition, I keep the negative 18, change subtraction to addition, and change the sign on the 10. So it looks like that. It doesn't matter how you work through it, as long as we all get the same answer. These are good ones to check, because if you end up with a negative or you had a negative in the problem somewhere, you should definitely check. So if I plug negative 18 back in for that variable in the original problem, I get negative 18 plus 10. Different signs I subtract, keep the sign of the higher number, and that does, in fact, equal negative 18. All right, number 4. Just because the letter's on the right side, it doesn't matter. Same process. I want to get the letter by itself. I want to isolate the y. So I need to get rid of minus 11 by doing the opposite, or inverse, and adding 11. So I'm going to add 11 to both sides. 22 plus 11 equals 33. Y is by itself. And then the answer is just turned around. And if I plug it back in, 33 minus 11 does equal 22. Okay, so number 5 looks a little weird because we have a negative 12 plus w. So some people might think, oh, well, it's added. The opposite of addition is subtraction. So I'm adding a negative 12. I have to subtract a negative 12. Well, when I see minus a negative, I automatically think, oh, I'm going to add the opposite. So I'm going to add positive 12. And to me, that's easier anyway, because I know negative 12 plus 12 is 0, it's a lot easier for me to go to the right side and add 12. To me, the more signs in there, the more mixed up I get. All right, so the left side is W, because negative 12 plus 12 is 0. The right side, I'm doing a negative 23 plus a positive 12. So different signs I subtract. 23 take away 12 is 11. And I keep the sign of the higher number. So the higher number is the negative on the 23, which means negative 11. Good one to check. So negative 12 plus W, which is negative 11, same signs, add and keep. So if I add them together, I get 23, and I keep the sign. So that one does work. So number 6 you can do two different ways. If you want to do what I did when I saw minus negative, I can automatically rewrite this as a plus 9. Because that's the same exact problem. So it's up to you. So if you want to do it that way, then all you've got to do is subtract 9. If you look at the way it was written, it says a minus negative 9. The opposite would be to add negative 9. Add negative 9. So the left side, that ends up being 0. And the right side ends up being the same answer we got here. So A equals 4. So these opposites, I think a lot of times these are easier because we don't have to worry about same signs add and keep, different signs subtract. So here I'm looking at negative 8 times R, so the opposite would be divide. And divide. Negative 8 divided by negative 8, it cancels out. And I'm left with R by itself. 56 divided by negative 8 is negative 7. Number 10. That negative out in front of that fraction, I'm going to put it with the 10. So that way the y is already positive. Divided by negative 10 equals 20. Opposite of divide by negative 10 is multiply by negative 10. That cross cancels. Y is by itself. 20 times negative 10 is negative 200. And last one, 4 times x, I'm going to divide by 4. So whatever the coefficient is, I'm dividing by it. 4's cancel. The x is by itself. 2 divided by 4, that is not 2. I can either reduce it and keep it 1/2, or if you prefer the decimal, it's 0.5. So either way is fine. Okay, last one. I want to look at a word problem. So Janelle spent $68 at the mall. When she left the mall, she had $43 left. How much money did Janelle have when she started at the mall? So actually, I'm going to go down to the second question. What does the variable stand for? Because I want to know what the variable even means before I write the equation. So to define the variable, I'm going to go back up to the question. It says, how much money did Janelle have when she started at the mall? So I'm going to use an M for money equals the money Janelle started with. That is how you define a variable. That just means tell me what you're trying to find. So let's go back up to the first part, write an equation. So she started with money, so she started with M. She spent $68. We know from writing expressions that we're going to subtract $68. And when she left the mall, she had $43 left. So this is the new part. We were writing all kinds of expressions. Now we know, okay, after the expression happens, she's left with $43. So now we can turn it into an entire equation with an equal sign. And then we're going to I guess I'll write that again. Wrote that in the wrong spot. I'm going to go ahead and do the opposite. So M minus 68, opposite would be to add 68. That equals 0. N equals, what does that equal? 11 plus, so answer, she started with $111.